Ladies and gentlemen, imagine this. You are watching a nature documentary about murmurations. Those breathtaking aerials dances with thousands of starlings move as one fluid organism. Now imagine that, but with artificial intelligence. Now I want to say welcome to multi-agent reinforcement learning, where we are teaching agents not just think as individuals, but as societies. I'm Julia Wang, and today we are diving into what I call the sociology of AI, because when brilliant minds start talking to each other, they either create miracles or beautiful disasters. Before we embark on this journey, let me set the stage for this adventure together. This video is the first one in our MARL Foundation series, a carefully curated collection of 5 or 6 episodes, each running about 20 to 30 minutes, designed to give you a solid grounding in multi-agent reinforcement learning. Please think of it as your passport to the world of collective AI intelligence. We'll start with the big picture today and then dive deeper into algorithms, applications, and cutting-edge research in the episodes to come. And here's the exciting part. This is just the beginning. Once you've mastered all the foundations, I'm planning an advanced series that will take you to the bleeding edge of MARL research. So buckle up, we are building your expertise step by step and video by video. Before we dive deeper, I want to hear from you guys. Please send me a barrage of bullet comments on what's the first word that comes to your mind when you think of collective intelligence. Is it ants, Twitter mob, orchestra, or chaos? Let's see what's on your mind. And speaking of the beautiful disasters, let me tell you about the day humanity got schooled by a video game. Okay, that's in January 2019. The eSport world held its breath as Alpha Star. Yes, that's Alpha Star. Google DeepMind's AI faced off against professional StarCraft 2 players. And I want to say this weren't just good players. These were the people who could macro-manage 200 units while planning 5 strategies ahead. And Alpha Star didn't just win, it dominated. But here's the kicker. Alpha Star wasn't one genius AI, it was a swarm of specialized agents. Each one an expert at something different, like resource management, tactical combat, and base building, all coordinating in real time like perfectly choreographed orchestra. The human weren't just beaten by superior computing power, they were outmaneuvered by superior teamwork. That's when I realized we weren't just building smarter machines, we are creating artificial societies. But before we got too impressed with our digital overlords, let's see how you handle coordination. Okay, now picture yourself approaching a 4-way intersection. No traffic light, no stop signs, no cop directing traffic. Just you and 3 other drivers, all arriving at exactly the same moment. Everyone wants to go first, everyone is in a hurry, and everyone is trying to read others' intentions through windshield and turn signals. So here's the quick question. In this scenario, what's your strategy? Are you the aggressive, I'm going first type, or the cautious, I will wait and see type, or I will make eye contact type? Please drop your personality in the chat. Okay. I really want to say that actually this macroscopic moment of human decision-making replicated millions of times daily is what exactly the MARL is trying to solve. Except imagine those drivers are learning, adapting, and evolving their strategies every single intersection. Welcome to the coordination problem that keeps roboticists awake at night. So what makes this problem so fundamentally different from everything we've done before? So here's the main bender. In traditional reinforcement learning, an agent learns to dance with a partner who never changes their moves. Boring, but predictable. Now, how about RL, MARL? Your dance partner is also learning, also adapting, and also trying to anticipate your next move. It's like trying to master tango, where your partner is simultaneously taking lessons from someone else. Every time you think you figure out the rhythm, they switch styles. So the environment isn't just dynamic, it's alive, it's thinking back at you, and that changes everything. And if we want to capture the beautiful chaos, we had to rebuild mathematics itself. Okay? Now we take an elegant simplicity of Markov decision process, one agent, one word, nice and clean. And then we need to explode it into what we call a Markov game. And thus, suddenly, every reward depends not just on what you do, but on what everyone does. It's the difference between playing solitaire and playing poker. In solitaire, perfect information and perfect strategy guarantee perfect result, right? But in poker, you are playing players as much as the cards. And that innocuous little joint action vector A isn't just mathematical notation. It's Pandora's box with a PhD in game theory. Okay, and inside that box lurks one of the most beautiful paradoxes in all of the mathematics. No, it's the Nash Equilibrium. The point where everyone is doing their personal best, given what everyone else is doing, sounds reasonable, right? But here's the twisted part. It can trap everyone in a collective, terrible outcome. The prisoner's dilemma isn't just a thought experiment. It's a prophecy. Yeah, that's a prophecy. Two perfectly rational agents, both making optimal decisions, both ending up worse off than it would just trusted each other. So time for the game theory get check. Imagine you are in the prisoner's dilemma with your best friend. What's your strategy? Do you cooperate or defect? Send your choice in the bullet comments, just tap cooperate or defect. No judgment, just curiosity about human nature. Maybe this is why your GPS sometimes routes you through traffic jams. Every car is optimizing for itself, creating the very congestion they are trying to avoid. So individual rationality can be collective insanity, right? And the algorithms have to navigate the philosophical minefield. Can it be done? Yes, but wait, it may get worse and much worse. Okay, now remember, when you learn to drive, you practice the same routes, memorize the same patterns, and build up experience. Now imagine every other driver on the road is also a student driver, learning at the same pace as you. So yes, these traffic patterns are useless because everyone is getting better at finding shortcuts. So this is non-stationarity, right? The cruel joke where your hard-earned experience becomes obsolete the same moment you earn it. Standard reinforcement learning assumes the world still holds while you learn, but multi-agent reinforcement learning laughs at that assumption. The world isn't holding still, it's getting smarter right alongside you. So you want to see how this plays out in the real world? Let me show you two of my favorite examples. Okay, the first one, gamers in the audience, I think you know this pain intimately. Maybe you spend months mastering a strategy, climbing the ranks and feeling invincible, and then developers release a patch or meta shift, or everyone discovered a new technique on Reddit, and suddenly you are back to square one. But here's what's fascinating. No central authority decided a new meta. It emerged from millions of players adapting to each other. So gamers in the audience, drop your pain in comments. What's the most frustrating meta shift you've experienced? When did your perfect strategy become totally useless overnight? Maybe stock traders feel the same whiplash. Your algorithms works beautifully, until everyone else's algorithms learn to counter it. You are not just predicting the market, you are predicting predictors predicting predictors. It's prediction all the way down, and the ground keeps shifting beneath your feet. And if that wasn't overwhelming enough, let me introduce you to the Exponential Monster. Okay, suppose there are 10 agents, 10 actions each. Sounds manageable, right? But wrong. That's 10 billion possible combination of joint actions. Not 10 billion state, not 10 billion reward, just 10 billion different ways for a single movement to unfold. And that's just 10 agents. Most interesting MARL problem have dozens, hundreds, or thousands of agents. We are not dealing with big data. We're dealing with mathematically impossible data. Let me put this impossibility in perspective with some numbers that will haunt your dreams. Okay, we know that Amazon's warehouses use hundreds of robots, and let's be conservative and say 100 robots, each with 5 possible actions. So the number of joint action is 7.9 times 10 to the power of 69. To put that in perspective, they are just roughly 10 to the power of 80 atoms in the observable universe. We are talking about numbers that make the universe look quaint. This isn't just a computational challenge, it's a fundamental reality check. We cannot, will not, and should not try to exhaustively explore this space. And the brute force isn't just inefficient, it's thermodynamically impossible. We need to be smarter than the universe. And fortunately, nature has been solving this problem for millions of years. Now look, Craig is sitting at his computer, frustrated with rigid, mechanical animation of the time. He read 3 simple rules: avoid crowding, match your neighbor's direction, and stay close to group. He runs the simulation and watches in amazement as lifelike flocks emerge on his screen. No central controller, no smarter plan, no GPS coordination, just 3 simple rules creating complex global behavior. This is emergence. The magic where the whole becomes greater than the sum of its parts. And it's become our North Star in multi-agent systems. We don't need to solve the impossible optimization problem. We need to design the right simple rules and let intelligence emerge. So fast forward to 2019 and emergence has gone to graduate school. Now, in this part, OpenAI gives their agents the simplest possible objective. Seekers find the headers. That's it. No menu about door blocking, no tutorials on wall building, and no seminars on strategic resource denial. Just find the other team. After millions of games, the agents developed strategies that would make military tacticians proud. Okay? Hiders learned to barricade doors, and seekers discovered they could use ramps to vault over walls, and hiders retaliated by stealing the ramps first. Okay, tool use, one of the hallmarks of human intelligence, emerged from digital natural selection. No programmer wrote, if surrounded, grab the nearest object and use it as a tool. The system discovered that tools exist and that they can be used and that controlling them is strategic. This is holy grail of AI, not programming intelligence, but cultivating it. To cultivating this kind of intelligence, we have developed 3 competing philosophies. Okay? Now think of these as 3 different approaches to organizing a society. The first one, CTCE, centralized training, centralized execution, is like having an all-knowing emperor who controls every citizen's action. Perfect coordination, unified vision, But what happens when the emperor becomes overwhelmed or makes a mistake, right? The number 2, CTDE, centralized training, decentralized execution. It's like having a brilliant academy that trains everyone together, sharing all the strategies and knowledge. But once graduation happens, everyone goes into the war to make their own decisions based on the shared training. That's more flexible, more scalable, but there is always that gap between what you learned in school and what you face in the real world, right? Number 3, DTDE, decentralized training and decentralized execution. It is pure democracy. Every agent learns from their own experience, makes their own decisions, and adapts to their local environment. Highly robust, infinitely scalable, but can anyone truly coordinate without some shared understanding? So, audience, which approach resonates with you? In the bullet comments, vote for your intuitive favorite, okay? And then we'll dive into this algorithm in our next episode. But I love seeing your instinct about how intelligence should work. Before we wrap up, let me summarize what we've learned into 3 unforgettable insights, okay? Now, the first, environment has gained consciousness. We are no longer teaching agents to solve puzzles. We are teaching them to navigate societies, right? The second one, the enemy isn't complexity, it's change. Non-stationarity and exponential growth aren't just technical challenges, they are existential ones, right? The third one is emergence is the secret sauce. The most beautiful behaviors aren't programmed, they are grown. As you design your own algorithms, don't just optimize for performance metrics. The goal should be designed for the unexpected, the creative, the emergent. The best solutions, I think, will surprise even you. But theory is beautiful. The practice is actually where the magic happens, right? So I think it's for the mission part. Your mission is, should you choose to accept it, become a social intelligence detective for about 20 or 30 minutes, immerse yourself in a real multi-agent system, watch gamers adapt to their strategies mid-match, or observe drivers navigating a busy intersection, or study shoppers in a crowded store. Watch traders to react to each other's move in real time. Don't just observe, just to investigate. What patterns emerge? What strategies involve? What behaviors surprise you? You are not only just doing homework, you are conducting original research into the nature of collective intelligence. So here's the quick brainstorm. In the bullet comments, suggest creative multi-agent scenarios I didn't mention. Where else do you see emergence happening in daily life? The weirder, the more unexpected, the better. And yes, you will need to document your discoveries. So if you want to, please write me a 300 or 400 word intelligence report. Who are your agents? What are their objectives? What emergent strategies did you witness? Most importantly, describe one behavior that caught you off guard. Something that makes you think, I never would have programmed that, but it's actually brilliant. This isn't just an academic exercise. You are training your eye to see the invincible dance of coordination that happens around us every day. So turn in the next week or next episode and prepare to be amazed by what you discover. So speaking of the next time, let me give you a preview of the main event. So in the next episode in our series, the topic is the algorithm war. 3 paradigms, 3 philosophies, 3 ways of solving the impossible. We will see them battle it out in arena of real-world applications. So make sure to subscribe and hit that notification bell so you don't miss the algorithmic showdown. So let me introduce you to the teams we need to discuss next time. Okay? The first one is Team CTCE, Centralized Champions. One man, perfectly harmony, but what happened when the mind becomes a bottleneck? CTCE asked the fundamental question, is perfect coordination worth the risk of perfect failure, right? Okay, the team number 2, Team CTDE, the hybrid heroes. The current champion, stable training, flexible execution, but dependent on that all-sealing training involvement. But here's the catch. What if the perfect information available during training disappears when it matters most? Okay, CTD embodies our eternal struggle between the ideal and the real. Number 3, Team DTDE, the distributed dreamers, the dark horse, fully distributed, infinitely stable, but swimming in the chaos of non-stationarity. DTD asks the boldest question, what if the best solutions can't be planned, only discovered? Okay, each approach embodies a different philosophy about intelligence itself. So in next episode, we will find out which philosophy wins when theory meets reality. So today, this stage is set and the questions are raised and your curiosity is hopefully piqued. Okay, so this is the end. I want to say the future of AI maybe isn't about building bigger brains. It's about building better societies. Thank you for joining me on this first step of our MARL journey. Remember, this is just episode 1 of our foundation series. We are building your expertise concept by concept. These questions you ask today will shape the algorithms of tomorrow. So please hit that subscribe button if you are ready to continue this adventure with me. The revolution in multi-agent intelligence is just beginning, and you are not just witnessing it, you are creating it. See you in the next episode. Bye-bye.